for this. The first thing we're going to learn is permutation and combination. Okay, so let's start with an example. Permutation, and we have combination, right? So we can also say this as arrangement. Okay, arrangement. So if we arrange 5, let's say we arrange 3 numbers out of 5 numbers. Okay, and we can also write down this way, P, and we arrange so we arrange 3 number from 5 numbers. So let's say we have 5 people here, 1, 2, 3, 4, and 5. So among these 5 people, we select 3 of them. Okay, 3 of them, they are selected, and these 2, they are not selected. And so what will be the permutation of this this event? So here 1, 2, and 3. So we can take the first person from any of these 5 person, like, right? So that's why the probability. So we can do the 5. We can take them 5 different ways. And then if we don't, if we have no repetition, then the next number, it will be it can be taken from it can be taken by 4 ways, right? And then the next number, it can be taken 3 ways. So, and the remaining 2 number we don't take, because we have to only take 3 numbers, right? So the answer will be 60. And here, if you do this is the permutation. Okay, this is the permutation. And for combination, so let's say we take firstly we take the first number 5. We can take 5 different ways, and the second number we can take 4 different ways, and the third number we can take 3 different ways. So here the combination order doesn't matter. Okay, the order doesn't matter. So we have to divide by 3, because these 3 number, they can also arrange in 3 different ways. So we have to divide by 3 so that we can omit those 3. Okay, and so the answer will be 60 by 3 factorial. So why I write 3 factorial? Because 3 number, let's say 1, 2, and 3, they can be combined. They can be rearranged in 3 factorial ways. Okay, 3 factorial ways. So 3 factorial means we have to multiply 3 and then 2 and then 1. If this is n factorial, so that means we have to start with n, and then we multiply into n minus 1, and then multiply n minus 2. So this way up to 1. Okay, so here it is 3 factorial, so it is 3 times 2 times 1. So 3 times 2 times 1 is 6. So here the answer will be 60 by 6. And that is 10, right? So here is the difference between a combination and permutation. So combination, here order doesn't matter. So we have to divide by the the amount of number we are taking, right? So here we take 3 out of 5, right? We take 3 out of 5. So that's why we divide here by 3 factorial. Okay. And then for permutation, here order matters. Okay. So we don't divide it by 3. And And if we come to probability, okay, so in that case, we have to divide by the whole number, right? So here we have to again divide by 2 factorial because we are omitting this 2 number, right? So we have to divide by 2 factorial. And here again, we have to divide by 2 factorial. So it will become 30. Sorry, 5 factorial. Wait. No, sorry. Not this one. Then here the permutation, the answer is okay. And for combination, so okay, so not to we don't need to divide this one because I will explain another way. So let's say, so the answer is right here, okay? We don't think of probability here. Just we can think of the formula. This is how we calculate without the formula, okay? And now we have to calculate using formula. So the formula for permutation, that is so we learned this way, right? We take 3 numbers out of 5 numbers, and then the formula will be, we can also write down this way. So P 3 of 5, right? So it will be 5 factorial by 5 minus 3 factorial, okay? Or we can say n factorial by n minus r factorial. N factorial by n minus r factorial. So here n is here is n, and here is r. So we take r numbers out of n numbers. That's why the formula is n factorial by n minus r factorial. And for the formula here for combination, it will be, so we write down this way. We take 3 numbers out of 5 numbers. So it will be like before n factorial, so 5 factorial, n factorial by, so we have to write down extra r factorial here, okay, r factorial into n minus r factorial. See, we have extra r factorial here. So if I use the formula instead of doing it manually, so it will be 5 factorial by r factorial. That means we take 3 numbers, right? Here n is 5 and r is 3. So 5 factorial by 3 factorial into 5 minus 3 factorial. So the answer will be 5 factorial, and so it is 5 factorial by 3 factorial into 2 factorial, right? So for 5 factorial, it is 5 times 4 times 3 times 2 times 1. So 5 times 4 times 3 times 2. 120, right? And for 3 factorial, that is 6. And for 2 factorial, that is 2. So 120 divided by 12. So the answer will be 10, right? So you see, both in both cases, we got the same answer, right? In both cases, we got the same answer here. Here is 10, and here is also 10. And if you calculate on the left side, you will also get the same answer. So it is 5 factorial by 5 minus 3, right? That is 5 minus 3, that is 2 factorial. So 5 factorial is 120 and 2 factorial is 2, right? So we get 60. So you see in both cases, we get the same answer, 60. So here is the difference between permutation and combination. Alex, do you understand?
Not everything, but you just keep going, man. I will try.
Okay, I see. So
thank you. Yeah.
If I summarize this, you can just use this formula, okay? N factorial by n minus r factorial is for permutation. And permutation here, order matters. That means I can, for example, I said 3 number out of 5 number, right? So I can even rearrange these three numbers. For example, if here is A, B, and C, so I can write down this way, right? A, C, B, and also this way, B, A, C. So like this, I can flip the number. So that's why we don't divide it by 3. And here in the combination part, here order doesn't matter. So we don't count the rearrange part. We just take them, right? We just select them. So that's why we have to divide by the r factorial, okay? Because we don't count the order. So if I divide by r factorial, so then the order part, I mean the rearrange part, that gets cancelled, and we only get the main answer. So you can just use this formula n factorial by r factorial into n minus r factorial, where you have to you don't need to count the order. Okay. For example, here we just take any 3 of number out of 5, but we don't rearrange them. Okay, we don't rearrange them. So let's see another example. If we have so if we have a question like the word football, so it is said that we have to arrange some, we have to make some we have to arrange it, we have to combine another word. Okay, so football can be arranged such that all vowels are always together. We have to arrange football, this word, so that all the vowels are always together. So here vowel is O, and here is O, and here is A, right? We have 3 vowels here. So if I write down this way, F, T, and then B. Okay, let me. Okay, let's say we take F, and then we take T, and then B, and then double L, right? And for these 3 vowel O and A, O and A, we just write them at the end, because it is said in the question that all vowels are always together. So we just assume that these 3 vowels, as they are all together, that means all of them are only on number. Okay, they are on character. So now, how many options we have? We have 1, 2, 3, 4, 5, and 6, right? So we have now six options, and so the answer will be. So let's say how many here the n is 6, right? And then we write down this way, 6 factorial divided by, and here if you see, we have 2L, right? Yeah, we have 2L. So if we have a number twice, so we have to write down, we have to divide it by 2 factorial. If we had 3L, so we had to divide by 3 factorial, and then multiply it. If you see here, we have 3 vowel, right? So O, and A, and then these 3 vowel, they can also get arranged. They can get rearranged in 3 factorial ways, or 3 times 2 times 1. That is 6 different ways. And so here we write down 6. And if you look closely, we have 2O here, right? So again, the same way, we have to also divide by 2 factorial, because we have same number here, same character here, O. So the answer will be 180 ways. So, okay. And now let's go back to something else. So let's go back to the distribution. Okay. So I'll share my screen again. So Alex, can you see my screen now? It's the PDF file.
I only see. Yeah.
Okay. So now let's go to statistics and see some distribution function. So firstly, we have a binomial distribution. So it's like a 0-1 distribution. We have only two options. So one is either yes and another one is no. Okay, yes and no. So let's say we flip a coin here. So we can get head or we can get tail, right? So this way. And there are only two potential outcomes per trial. It's the binomial distribution. And the probability of success is the same across all trials. So if you flip a coin, so probability of getting head, that will be 50%, and probability of getting tail, it will be also 50%, right? So what is probability? Probability is the number of favorable outcomes divided by the number of total outcomes, right? Favorable by total. So here we have a head and tail. So for head there is on, and for tail there. So for head and tail together there is two different ways, right? And then either we can get head or we can get tail. So we have only one option here, right? So the probability of this event, it will be 1/2, or that is 0.5 or 50%. Okay, and so here binomial distribution, the probability of success is the same across all trials. So we have 50-50 possibilities here. That's why it is binomial distribution. And then another property is the numbers of trials n is fixed. So how many times we try, it's already defined, and each trial is independent. So either I get head or tail doesn't affect the next event. Okay. For example, you have three pen. Okay, one is red and another one is blue and another one is green. So if your friend takes the red one, so it will affect the next outcome, right? Because you cannot take the red pen. So here this is not independent. Okay, but here for binomial distribution, each trial it have to be independent. And let's see an example. Probability of color blind. So probability of color blind, that is 0.08. And here we have 10 people. We have 10 people, and the probability of being colorblind is 8%. Okay, 0.08 means 8%. And so the first question here is probability of all of them are colorblind. So we just write down this formula, p to the power n. So probability of being colorblind is 0.08, and we have total 10 people, right? So 0.08 to the power 10. This is the probability of all of them being colorblind. So it should be very small probability, right? Okay. And then if I calculate 0.08 to the power 10, it is a very small probability. So on 0.07 times 10 to the power minus 11. So very small probability, okay? And let's see the next one. None of them are colorblind. So if this is the colorblind, so none of them are colorblind. So we know that P, it represents probability of colorblind. So if I draw a rectangle, so let's say this part is colorblind, and we want them now. We want none of them are colorblind. So we want this part, this white part, right? And so if the whole thing, that if the whole probability that is 1, and then this white part, it will be on minus. So this part, the colorblind part, this is P, right? So it will be 1 minus P. So probability of none of them are colorblind, it will be 1 minus P to the power n. Okay. So 1 minus, so here P is 0.08. 1 minus the probability of being colorblind. So 1 minus 0.08 to the power 10. So 10 is the total number of people. So we get minus 0.92 to the power 10. And the next question, probability of 2 of them are colorblind. So here is the probability of colorblind, and here is the total number. Here is the number. So here it is said 2 of them. So we write down here 2, and times if 2 of them are colorblind, and then the remaining 8, they are not colorblind. So again 1 minus 0.08, it represents not being colorblind, right? Because you know here is 1 minus P. So 1 minus P, it is this part, they are not colorblind. So 1 minus P is 0.92. So we multiply with, so here is the people, those who are colorblind. So 2 of them are the probability of 2 of them are colorblind times probability of the remaining 8 people, they are not colorblind. And then these 2 of them, they can be also combined 2 different ways. So we write down 10C2, okay? So we multiply using 10C2. So this is the answer of probability of 2 of them, they are colorblind. And if it said at least 2, it means at least 2 of them have to be colorblind, and it can be also 3, 4, 5, up to 10. So from 2 up to 10, right? From 2 up to 10 people, they can be colorblind. So here the probability will be 1 minus. So if I write down another, if I draw another rectangle. So here let's say 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at least 2 of them, that means from here up until here, right? Here is 10 and here is 1. So here is 2. So from here up to here. So the whole part here is 1, right? The total probability here is 1. And then we minus the probability of the people, those who are colorblind and they are less than or equal to 1, okay? So if you see here, sorry, we have on here, right? There is 2, and let me change the color. Okay. Here is 2. So here is on, right? So on starts from here, okay? On starts from this line. And then this part, this is the probability of being colorblind from 0 out of 0 and 1. Okay, 0 and 1. Only 0 and 1. None of them can be colorblind, and on people can be colorblind. So this blue part here, this is the probability of being colorblind, either 0% or 1%. And this red part here, from 2 up to 10. So this part is the probability of being colorblind. At least 2 of them is colorblind. So this part is here. So we say that the whole part, this is 1, or we say total probability, and then we minus this part. So then we get here. Then we get this part, right? This part here. So this part is for at least 2 of them are colorblind. So it can be 2, it can be 3, it can be 4, it can be 5, 6, 7, 8, 9, and it can be 10. So this is the answer. On minus probability of being colorblind, and that is less than or equal to 1. So here x is less than or equal to 1. So we just omit this part from the whole part. Okay, because this part is less than or equal to 1, but we want greater than or equal to 2. So you can ask me like, so between 1 and 2, there is some number, right? There is a 0. Sorry, there is 1.5. There is 1.6. So if you see the condition here for binomial distribution, okay, so this is a discrete random variable. Okay, binomial distribution, they are discrete. So what does discrete means? Discrete means, so let's see an example, like if you count number of people entering the classroom, it can be either 1, 2, 3, right? You cannot count this way, like 1.5 people, 2.5 people, right? Not this way. You can count the 1, 2, 3 this way. I mean natural number. This is a natural number, right? Yeah. So this is called discrete. Like I cannot get any point number. I will always get a integer number. Okay. So that's why between 1 and 2, we don't count any number. So Alex, do you understand this one? Probability of at least 2 of them are colorblind. And probability of x is equal n. So let's say, so this is the formula here. NCX. So here x is the number of people we are considering. So n is the total number of people, and x is the number of people we are considering. So here this is 2 of them. That means you see here 10 C2, right? So n is the total number of people, and x is the number of people we are considering here. And then p to the power x, that represents, you see here the probability, and then power n. So here 0.92, this is the probability of not being colorblind, to the power n, that is the total number of people. So if 2 of them are colorblind, then remaining 8 of them, they are not colorblind. So here 0.92 to the power n, or that is 8. So p to the power x, and then 1 minus, sorry, p to the power x is here 0.08 to the power 2. If I remove this part, you see 0.08 to the power 2. That means p to the power x. Here the probability of being colorblind is 0.08, and the number of people we are interested here is 2, right? 2 of them. So here the power will be 2, and then 1 minus p to the power n minus x. So here you see 1 minus p. So 1 minus probability of being colorblind. So 1 minus 0.08. It will be 0.92. So here is 0.92, and then to the power n minus x. So we already took 2 of them, right? And then remaining 8. I mean, so here will be 10 minus 2. That is 8. So remaining 8 of them, they are not colorblind. So we multiply this probability. So and see here 10C2, it is the NCX. So I have written the formula here clearly at the last part. So this is how we calculate a binomial distribution, okay? And in Microsoft Excel, there is a formula to calculate the binomial distribution. That is binom dot distribution. So the first number here, that is okay. So you see here all of them, right? So if you see here none of them. So if x is equal to 0, that means none of them are colorblind. So here the value of x is here 0, and then 10, this is the value of n, and 0.08, this is the value of p, and false, it means it's the cumulative. So we have two kind of distribution. One is cumulative, and another one is maybe probability mass function. So in this case, it is false. That means we are only interested in a particular in just one value, right? Here x is equal to 0. So this is on value. So here we write down false here. But if you look here, at least 2, right? If you look here the probability is x is greater than or equal to 2. So this is not just 1 point. This is from this is this part, right? The pink part I have marked here. So it is not only 2, it is 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why it will be in the Excel, Microsoft Excel, we write down here true if this is not just 1 point. And if it's like 1 point, so here you see x is equal to 0, that means it will be false. So in Microsoft Excel, we can also calculate the binomial distribution. Oh, Alex, do you understand?
Not everything, but yeah, as I said, it's okay. Just keep going.
Okay. So I will try to explain more simply, okay? Because I feel like I'm bad at explaining, but okay, I will try to do it more simply. The expected number of colorblind men in the sample. And so here you see I have classified something else like the before. The expected number of colorblind men in the sample. So we write down this way, expectation. You know, our teacher, she explained a lot of time, she mentioned this thing like expectation. So the expectation will be n times p. So we have 10 people here, and then there is the probability of being colorblind is 0.08. So if I multiply them, it will be 0.08. So this is called the mean, okay? This is called the mean. When we draw the graph, so in the graph, it is the mean. And the standard deviation of the number of colorblind men in the sample. So it's standard deviation. So what is a standard deviation and what is mean? Let's see here. You see a graph here. This is the normal distribution graph. And this is the x-axis. And this is the y-axis. So let's say we have some data here. This circle, there are some data, okay? And if you look here, most of the numbers they are here, right? They are here in this part. And this data, this is far. So somehow all the data they are going to they're going to place this way, right? They are going to, okay, they're going to being placed here, right? So this is the mean, okay? This is the mean. And we can also represent it as mu. So this is the mean, okay? And so what is a standard deviation? Standard deviation is sigma. Sigma. So it represents how this it represents how many samples it represents, like, so let's say we have a graph this way and we have a graph this way, okay? So this is thin, right? That means the standard deviation sigma, the value of sigma is less. And here, this graph, it is fat, right? It is fat. That means the sigma is fat. So the value of sigma, it is large. So the value of sigma here is small. And the value of sigma here is large. So sigma represents where is the data, right? Like how closely the data are. Are they very closer or they are far from each other? Or how big my sample space is, okay? So it sigma represents this way. A standard deviation is represents what is the width, what is the width of this graph, okay? And I think you get some idea like what is standard deviation and what is mean. And for variance, so variance means if we just take let's say this event or this sample, I will use different color. Let's say we take this sample, and this sample is far from the mean, right? So the variance, it represents how far this sample is from the mean value. Okay, so this is the standard deviation and mean and the variance. So this thing will come so many times when we learn some distribution. So let's come back here. The standard deviation of the number of colorblind men, in the sample space. So we represent a standard deviation with sigma, but here it is represented as v of x. So that's not a problem. And the formula is np into 1 minus p. So here n is 10 because we have 10 people, and the probability of being colorblind 0.08, and 1 minus p, this is probability of not being colorblind. So not being colorblind is 0.92. The answer will be 0.736. And then we can also calculate it using the sigma equal to a square root of dx. So a square root of dx. So this is also said as dx, okay, not dx. You can also say dx. So v for variance, okay. So d also for variance. So sigma equal root over dx. So 0.858. This is the standard deviation. So I have given a note here, sigma equal root over dx. And let's say what is Poisson distribution. Poisson distribution is also a discrete distribution. So when we do the graph, we will get 1, 2, 3, okay? This kind of discrete value. We cannot get 0.5, we cannot get 2.1, okay? We just get integer. So for example, number of people. They cannot be 0.5 or 0.7, right? They can also, they can only be a integer, and describes the number of events occurring in a fixed time. So it is important, in a fixed time interval. So in Poisson distribution, in the question, there is often said some time, right? In this fixed amount of time, some visitor comes in my website, or this fixed amount of time, like within 1 hour or within 30 minutes, 5 students, they goes to the supermarket, or this way, okay? There is some fixed time interval. So Poisson distribution, it's related to time. And it requires only one parameter, that is lambda. So lambda, you can also think it as a mean, okay? Lambda is like a mean, and it's bounded by 0 and infinity. So here probability mass function. So probability of x is equal x. That means let's say the probability of x is equal to e to the power minus lambda times lambda to the power x by x factorial. So we will see an example. Let's say we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. We have 10 people here. And if I ask you probability of, so here lambda is given, the mean is given. So let's say we have a website, and we get some visitor, and we count how many visitor we get within 1 hour, okay? How many visitor we get within 1 hour. So in the question there is said, what is the probability of getting 5 visitors here, right? What is the probability of getting 5 visitors in 1 hour, okay? So then you see here the point 0.3, it represents 30%, 0.2, it is 20%, and 0.1, that is 10%. And so for 5 visitors, the probability is 0.1, right? And if I just connect these things, the upper part, so I will also get a graph this way, right? So the sigma is here. How wide, okay? How wide the graph is. It is a sigma. So the probability of getting 5 visitors within 1 hour. You see here, we there is some time, but there is some time interval. So Poisson distribution, they are related to time, and the probability of getting 5 visitors within 1 hour, that will be 0.1. So this is an example of Poisson distribution, and this is the formula for Excel. And standard deviation, this is root over variance, as I mentioned just now. So standard deviation sigma, that is equal to root over dx. That is a square root of variance. And expected value, we can also say this as expectation. Expectation E of x, it will be lambda, and variance V of x, it will be also lambda. Because in Poisson distribution, it only depends on one parameter, that is lambda, or that is the mean, okay? Mean. That is the mean. So here lambda is given in this example. Lambda is given. So I think you got a brief idea of Poisson distribution. Alex, do you have any question here?
Yeah, you can keep going.
Okay. And then we have hypergeometric distribution. So it is also discrete distribution. So here x belongs to n. As I mentioned, like we can only get discrete numbers 1, 2, 3. Okay. So here x belongs to n. This is also the same before. It's a discrete distribution. is equivalent to the binomial distribution, but without replacement. It is the same as binomial distribution, but without replacement. That means once we take a number, then we cannot put it back, okay? We cannot put it back. It means without replacement. As I mentioned, like if you have 3 pen, red pen, blue pen, and green pen, if your friend takes the red pen, so you cannot take the red pen, right? Because that's already taken. So you can only take blue and green pen. And the probability of a success changes with draw. So you see here, your friend took the red pen. So the next probability, you cannot get the red pen. So the probability of a success changes, right? Okay, and then defined for 3 parameters. So it's dependent on 3 parameters. One is n and a and n. Here is capital N and here is a small n. So capital N represents total population size, and a small n represents the sample size. So you take some sample from the total. So you have some apple, right? And then you just take the green apple. You don't take the red apple, okay? You just take the green apple. So this way, here green apple, that is n, and here the number of apple, that is capital N. So total population size, and here a small n is sample size, and a is total items of interest. Total items of interest in the population. And here n, here x is number of items we interested in the sample. So you see we have 2 different things. Here is sample, in the sample, okay? And here is in the population. So here sample is a narrower part, okay? Like here for green apple, you can think like how many of them are good and how many of them are bad, right? So this way. So the PMF function or probability mass function, it will be P of x equal x. So we take some sample here from the total interested items of the population times n minus a by n minus x divided by n by n, okay? So in this this example is for like card poker hand. So it is maybe a card game. So you have a total 52 card, and then a, maybe this is I'm not sure. There is some different classification of card. Like one is maybe a star, okay? So there is different types of card. So and here n equal 5. So you take 5 out of 13, okay? You take 5 out of 13. And let's say you are interested only in 2 cards. So those who know the card poker hand, this game, so it's a card game, they will understand this one, okay? This distribution. And so here again we have some formula for Excel, Microsoft Excel. Either we can use this formula and we calculate by our hand, or we can use Microsoft Excel to calculate this part. And then let's go back to the exponential distribution. The time between events is a Poissonian process. So exponential distribution, it's just exponential. Exponential is called e to the power x, right? It's the inverse. It's the inverse of Poisson distribution. So in Poisson distribution, let's say we have a number of cars passing a toll gate in 1 hour, right? So we are interested in number of cars. But in exponential distribution, we are interested in time, number of hours. Here we're interested in number of cars, but here we're interested in number of hours. So we have 2 difference, right? One is here we are interested in number of cars, and we are interested in number of hours between car arrivals. So another example, number of soldiers killed by horse kick per year. So you see we are interested in number of soldiers, but here we are interested in number of years between horse kick deaths in Persian army. So here we are interested in time. So exponential distribution, it's interested in time, and Poisson distribution, it's interested in the number of events. And then events per single unit of time. So yeah, I have already written here. I have already told that here Poisson distribution, we are interested in number of events per single unit of time. So single unit of time, it can be 1 hour, it can be 30 minutes. Okay, it depends on how we draw the graph. So it can be 1 hour or it can be 30 minutes. And for exponential distribution, it's the time per single event of our time between events. So you see here we're interested in time. So time per single event or time between events. So let's say you have some visitor. So here is a function. Here you see, here is a graph here. Events must occur at a constant rate. Okay, so we have two conditions here. The first condition is events must occur at a constant rate. So if you have some visitor, like if I tell you like the mean is 3, so in 1 hour there must be 3 visitors, and in the next hour there will be also 3 visitors, and in the next hour, in the following hour, there will be also 3 visitors. So events must occur at a constant rate, and events must be independent of each other. So one event doesn't affect the another one. That's called events must be independent. Like if you get one visitor now, if you get 3 visitors in 1 hour, it will not affect the next hour. You can also get 3 visitors in the next hour. Okay. So here is 2 conditions. And so let's say we have exponential distribution here. So previously we learned Poisson distribution, right? So as we know, exponential distribution is the inverse of Poisson distribution. So if for Poisson distribution, the lambda, if the lambda is 3 or the mean value is 3, then in exponential distribution, we call it mu, okay, mu. And then mu is inverse, like, so if I write down 3 inverse, it will be 1/3, right? So that's why mu is 1/3. So this is the relation between Poisson distribution and exponential distribution. So you see, we have a 0 hour, and then we have 13 half hour, and 1 hour, and 1.5 hours, 2 hours, and this way. And then you see the function here and the graph here. So it is like an exponential way. We know that the exponential function, it is this way, right? Either this way or it is this way. So it's the probability density function, and it's the graph of exponential distribution. So let's see another example. We have some minutes here: 0 minute, 30 minutes, 60 minutes, 90 minutes, and 120 minutes. So this is the value of x, right? Okay, here x minutes. And let's say we have a website, and we are counting the visitors. So the first question here is, find the probability that next visitor arrives within 10 minutes. You see, we are said here to find the, we are just interested in the time. As I mentioned above, exponential distribution, they are interested in time. So find the probability that the next visitor arrives within 10 minutes. So here is 0 and here is 30. So 10 can be here, right? Maybe here is 10. And so we are interested in this part, the pink part here, right? I have marked here A, this part. We are interested in this part. So from 0 to 10, from 0 to 10. We are interested in this part. And find the probability that the next visitor arrives within 10 minutes. So here the x is less than x because we have x here is 10 minutes. So we have 120 minutes. So 10 minutes is less than 120 minutes. And then the formula is 1 minus e to the power minus x by mu, right? 1 minus e to the power minus x by mu. So here x, this is the this is the time that we are interested, right? Within 10 minutes. So here x is 10 and mu. So you already know that mu is given. Mu is the mean, right? The mean is 20. So here it is 20. And then the answer will be 0.39347. You can calculate using the calculator. So, and here we have also a Microsoft Excel formula, exponential distribution, x and then lambda. So here lambda, we know that lambda was in Poisson distribution, but it converts to mu in the exponential distribution. And we know that if lambda is equal to 3, then mu will be the inverse, like 3 inverse. So it will be 1 by 3, right? It will be 1 by 3. So that's why here lambda, it is 1 by 20 or 1 by mu. On by, yeah, see, so here lambda, on by, not on by mu, it's, yeah, it's on by mu. And then cumulative distribution, that means we are interested, here you see, we are interested a region, x is less than 10. So that means from 1 to 10. Here is a region, right? From 1 to 10. We are not interested in a particular point, but here we are interested in a particular area, like as I have draw here, as I have mentioned here, right? We are interested in a particular area. So that's why that is the cumulative distribution. Okay, we are interested in this part, right? From 0 to 10, we are interested in this part. That's why it was x is, it was okay here, x is less than 10, right? And so here it is cumulative distribution. And for here, that's why in Excel we write down here true. Okay, we write down here true. And so Excel will give us the result 0.3934. And let's see the probability of so after 30 minutes, how many, find the probability that the next visitor arrives after 30 minutes. So here after means x is greater than 30, right? So the formula is 1 minus e to the power minus x by mu. So, okay, so I forgot to write 1 minus. Then so the x, so here x is 30 because we are interested in 30 minutes, and here mu is already given 20. So the answer is 0.02231. And also here we have the formula for Excel. And then, so we have finished the distribution part. And now let's see what is mean, what is variance, and what is standard deviation, and how they are represented, and what that really means. So the first one is mean, right? So mean is represented as this way, x mean. So if we have if we have 3 students, they got 15, another one they got 20, and another person they got 10. So what is the mean? We just add them together and we divide it by the number of people. So we have 3 people here, so it divided by 3, right? Okay, so the mean will be 45 by 3. So it is 15, right? So this is how we calculate mean. And here x bar, it is a different mean. It is the estimated mean, okay, or the sample mean. It is not this kind of simple mean. is the estimated mean, because if we have a large amount of data, then we cannot do this by hand, right? We have to use this kind of formula. So here X bar, it means estimated mean or sample mean. And here mu is the population mean, okay? Estimated mean and population mean, they are two different. They are different. Estimated mean and population mean. So population mean, it is very exact number. Like as you see here, I have a count here 15. But if we have if we have 1 million students, so can we really count them? Or if we have 1 million people, we cannot count them using by our hands. It's a very long process. So then what do? We just split it and we take some few number. It can be maybe 10 or 100. Okay, we take some few number from them and we try to find the estimated mean. Okay, so and population mean, so the main difference is population mean it's very specific, and estimated mean it's not specific. We just split the total population and we try to estimate some mean. Okay, and the formula to find population variance, we can also say this as a variance. So d of x, variance d of x is summation of x minus mu whole square divided by n. So here x is the each given data, right? It's the each given data. So when you're interested in, like as you have seen before, we were interested in 10 minutes, right? Or so we were interested in some specific data. So that is x, and mu is the population mean. So in the previous example, mu was given, right? Here you see mu in the function here, mu is 20. So mu is like a mean, okay? It's like a mean where the data are more likely to be found, right? That is mean. And then n is the total number of data. How many number of data we have? It can be 1 million, it can be 100, it can be 1000, okay? And population is standard deviation, that is sigma. Sigma equal to root over dx. Standard deviation sigma, that is equal to root over dx. That means root over variance. And here f of x equal phi x minus mu by sigma. So sometimes we will also find f of x. So it is to convert it to a standard form, okay, standard form. We will have a look in them in the homework part. And estimated population variance. So it is also population variance, but it is estimated, right? Estimated. So most of the case we will use this formula because we don't play with some small data. We deal with some big data, right? So that's why it is estimated. So the formula is summation x minus x mean divided by n minus 1. This x mean, this is estimated mean, right? Here you see estimated mean. So most of the case we will use estimated population variance, or we will use this formula, summation of x minus x mean by n minus 1. Summation of x minus x mean whole square by n minus 1. And you have to know that the estimated mean, it is always smaller than the population mean, okay? Estimated mean, it is always smaller than the population mean, okay? And estimated population is standard deviation. So our standard deviation for the estimated population is standard deviation. So it is estimated. It will be root over summation of x minus, so we just find the square root of summation of x minus x mean whole square by n minus 1. And estimation population mean, the mean will be sum of measurements by the number of measurements. You know, we already know that mean is the sum of measurements, and then we divide it by the number of measurements. So, and what is likelihood in statistics? So likelihood is the same as probability, okay? It's a fancy name, but it depends on some more data, okay? So likelihood is like a probability. So you see here, we just add the number, add the data, and then we divide by the total number. As you know, as I said here, mean will be the sum of measurements by the number of measurements. So this represents mean, and maximum likelihood. Likelihood is the probability. So maximum likelihood is if you see this data here, if you see this graph here, the maximum likelihood is here, okay? Here you see the peak point, and it will be here the derivative. Here the derivative will be 0, okay? Because you know that derivative of a line that is parallel to x-axis, right? So if we have a graph here, so in the peak point, on the peak point here, the derivative will be 0, right? Because here the slope is equal to 0, okay? So we know that slope is equal to f is equal to tan theta. So here theta equal to 0, right? So tan 0 is equal to 0. So here the derivative, or the derivative of this peak point, it is 0. So when we find the likelihood, the maximum likelihood, it means we have to find where the derivative is 0, okay? It means we have to find where the derivative is equal to 0. And here it is a normal distribution. I have already explained here above. So as you see, we have some data here, and sigma, it represents how wide our graph is, and this part, this the middle part, it is the mean. So we also call it as mu, or where our data is more likely to be found. And here the x-axis, it is the given value, like the given data. Here the circle, I represent this as some given data. And then the variance, it means how far. So if we are interested in this data, let's say we are interested on this data. Let me change the color. Okay, we are interested on this data, and it is, so variance means how far it is from the mean value. And so that is called variance. But it doesn't. But it has a formula. I have already shown you here variance. See here variance, the population variance dx. So here the formula is summation of x minus mu whole square by n. So this is the variance, okay? But in graph, it is like how far the data is from the mean value. And 95% of the measurement fall between plus or minus sigma times 2, okay? Plus or minus 2 standard deviations around the mean. So what it means, so let's say xy axis, and we have some function this way. We have a graph. It is a normal distribution, and here is the mean. Here is the mean. Here is the x for our given data, and here is the sigma. This is the sigma, okay? So 95% of the measurement fall between plus or minus sigma times 2. So if sigma equals, so sigma will be given, okay? If sigma equals 1.5, so you will see that sigma times 2, that is 3, right? So plus 3 will be 1, 2, 3. Plus 3 will be here. And minus 3 will be 1, 2, 3. Minus 3 will be here, right? So most of the data will fall between this region, okay? So that's why you will see this graph so many times. So it's so here I end the distribution part and also some basic part. Now we will go to homework part. Alex, are you still here?
I'm here.
Okay, so do you really understand, or how much do you understand? 50%?
Yeah, I would say half of it.
Okay.
Because that's not it's not about your explanation, it's about me, man. So don't worry.
Oh, okay, I see. So let's go to the homework part, okay? Homework part is here.
Do you cover Python here or only math?
I'm very beginner at Python, so I just copy the codes from Yunus and Reda. But I'm trying to learn from the video from Angela Yu, you know, and also I have the recording of our Laoshi, so I uploaded them. I uploaded them on YouTube. So when I get some spare time, I just review those. And I'm very beginner at programming. I learned JavaScript, but it was 3 years ago.
Oh, you learned JavaScript 2 years ago.
But this basic level, okay. So I know I can understand the code, but I don't know how I see, but I cannot solve the problems, okay? Because you know programming, it requires practice, but I don't have that practice. But after the math examination, I will try to learn by myself, and probably it will be, I'll try to solve the problem by myself.
Okay. Do you have Discord?
Yes, I have Discord.
You know, on Discord, there's a Python community that can really help you have problems.
Okay, I'll join. I'll join after this session.
Just search for Python on Discord, and you will see like there's a very big community, and the rooms would help. So if you need help, you can type your problem to them, and they'll reply you really fast.
Okay, sure, I'll do it. So now let's start with the first homework. Oh, I have to share the question also. Oh, I'll take a phone call, okay? Just a moment. The first question here is, let A, B, C are random events. Denote the following events using A, B, C. So the first question, A occurs and B and C do not occur. So you see when A occurs, so we write down A, and B and C do not occur. So AND is for intersection, you know, intersection. So AND, right? AND is for intersection. And B and C, they doesn't occur. So doesn't occur means this sign, okay? And also we can omit this AND part. So we can write down this way, A, B, C. So A, B bar, and C bar. So it means B and C doesn't occur, but A occurs. That's why the answer is A, B, and C. So A, B bar, C bar. The second question here is A and B occur while C does not occur. The same way A and B occurs, but C does not occur. C bar, A, B, C bar. All three events occur. That means A, B, C. Or you can also represent it as A intersection B intersection C. At least one event occurs. It means at least one. That means it can be either A, or it can be B, or it can be C. It can be any event. So we write down A union B union C. So union, you have to know that union it represents OR. Okay, it represents OR, and it is plus sign, addition. And intersection, it represents and it is the multiplication sign. Okay, so we can also write down this this way: A union A bar, B bar, C bar, intersect, then whole bar. So we don't need to mess up with this part. Just A union B union C, and then all three events do not occur. It means A doesn't occur. Yeah, it means A doesn't occur, and B doesn't occur, and also C doesn't occur. Okay. Or you can also write down this way: A, B, and C, all of any of them occurs, and then the NOT sign or bar sign. So it means all three of events do not occur, or none of them occur. And the second question here is let A, B, C, let A, B are random events. So probability of A is given 0.7 and probability of A minus B is given 0.3. Calculate the probability of A, B inverse. So, so for two events A and B, you have to know the formula. If I go here, the formula is probability of A minus B. Probability of A minus B, that is probability that can be also written this way: probability of A B bar. Okay, A B bar. So you just write down this minus sign here. So it will be probability of A. So the first one here, probability of A, then minus their intersection. That means probability of A and B. So here in the question, it is said that we have to find probability of A B inverse, right? So let's find probability of A B first. Let's find probability of A B first. That means probability of A intersection B. So that is P of A minus P of A minus B. So just you just take this part on the left side and you take this part on the right side. Okay, then you will get this this line. It's not very difficult. Just change the position of the equation, and then this minus sign will become plus sign. You see AB, it becomes plus, and then this plus sign will become minus sign. Okay, here it is minus. So P of A is already given 0.7 and P of A minus B is also given 0.3. You will see here P of A and P of A minus B is given. So why we why we use this formula, or why we just take them on the left side? Because we already have the value of P of A and P of A minus B. That's why we convert the or we use this equation. Okay, or we exchange the side, and then the value is 0.4. And now let's find what is probability of A B inverse. So if I say A inverse, it means 1 minus A. Okay, 1 minus A, because we know that the probability can be between 0 to 1, right? The value of probability is between 0 and 1. So 1 is the total probability. And so here A bar, it means 1 minus A. Okay, so P of AB inverse, it means 1 minus P of AB. So P of AB is 0.4. So 1 minus 0.4 is 0.6. And then the third number of homework 1. Let A, B, and C are random events, and P of C equal 1/3, P of A equal P of B equal 1/4, and P of AC equal 1/12. So you have to calculate P of AB equal to, okay, so we have more value, P of AB equal P of BC equal 0. And then we have to calculate the probability of at least one event occur. So we know that at least one event occur, that means P of A union B union C. So it has a big formula. Here it will be minus. Okay, here it will be minus. So if you see here, the formula is probability of A plus probability of B plus P of C, then minus P of AB minus P of BC minus P of AC, then plus their intersection, okay? Their intersection, P of A, B, C. So P of A is given, P of B is given, P of C is given, then minus P of AB and BC are 0, right? So this part is 0. And P of AC is 1 by 12, right? So here is minus 1 by 12. You see here minus 1 by 12. And then plus P of ABC. So if you look back here in my notes, in my homework, so you see I have already assigned the value here, P of A, P of B, P of C, and then P of AB, P of BC, and minus P of AC, and then plus P of A intersection B intersection C. But you also need to find out what is P of A intersection B intersection C, because this value is not given. So let's see how can we find it. So you know that P of A intersection B intersection C, that is P of A intersection B times intersection C, right? Because, okay, so P of A intersection B intersection C, you can also divide it by this way, like you can just separate them, okay? Separate them. So this is the same, okay? This is the same. So we know that P of A intersection B is given. So A intersection B is given 0. You see, P of A intersection B here, it is given 0. And so we know that this sign, intersection sign, it represents and it represents multiplication. So we just multiply this, and probability of C, it is given 1 by 3. So times 1 by 3. So if I multiply them, the answer will be 0, right? That's why I have written here 0. So now if I add them up, I will get 3 by 4. And the next one is take any telephone number in the telephone directory and find the probability that, so telephone number, it consists of 11 digits, right? And then find the probability that the last 4 numbers are all different. The last 4 numbers are all different. So if I write down here last 4 numbers, right? Okay. So let's denote the last 4 numbers are all different. So A is an event. So here the last 4 numbers are all different. So there are 10 to the power 4. You know, the formula P to the power K. So we just take 4, right? So P to the power 4. As you see here, okay. So 10 to the power 4, this is. So this is the total probability, okay? 10 to the power 4. So P to the power 4, 10 to the power 4. This is the total probability. Total probability. And so there are 10 to the power 4 kinds of combinations of the last 4 numbers. And each combination is equally possible. And then 10 where this 10 comes, because I denote the last 4 numbers are all different. Okay, so as you know, that telephone number, they are 11 digit, but the first digit, it cannot be 0 maybe. So that's why we just 0, 1, 2. Oh, sorry, no. But in telephone number, it can be from 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in total, there are 10 numbers. In total, there we have 10 numbers. That's why we have written here 10 to the power 4, because we have total 10 number and we have to fill up four box here. So that's why it is 10 to the power 4. And this is the total probability. And each combination is equal. Okay, and there are, so we take here permutation, you know, permutation. We take 4 number out of 10 number. That's why it is a 10 out of 4. There are a 10 out of 4 kinds of combinations that the last 4 numbers are all different. So, you know, the probability will be the outcome, right? The outcome here is sorry. Yeah, so the outcome here is a 4 out of 10. That means permutation. So we can write down this way, p 10 out of 4. So it's a 4 out of 10. And then on the denominator, here is the total probability, right? So the outcome divided by total probability. So the answer is 0.504. So this is the answer. So if I write down here, so let's say we can take we can fill up this box from, okay, maybe I don't need to explain further, just we can just use the formula. And manually understanding is also good, but maybe I explained this part, what is permutation and what is combination in the very beginning part. So we just use the formula here, okay? And then the probability of an animal living from birth to 30 years, birth to 30 years old is 0.9, and the probability of living 40 years old is 0.5. What is the probability that the 30-year-old animal will live to 40? So 30 years old animal will live to 40. That means it has already passed 30 years. So this is the condition, okay? And we want it to live at up to 40 years. So now let's denote A is equal the living from birth to 30 years. So it's given, right? It's given 0.9. And B is living from birth to 40 years. Is also given 0.5. And then B is contained in A, okay? So you know that B, here B, so B is 0.5. So 0.5 is already in 0.9, right? Because the total probability is 1. So let's say it is 30 and 40, right? 30 years and 40 years. So in 30 years, it has already, it's the probability is 0.9, and 40, the probability of living is 0.5. So you see here, 0.5 is already between 0.9, right? If I draw a line here, here is 1 and here is 0. So here is 0.5. And maybe here is 0.9, right? 0.9. So you see here, if I have 0.9, sorry. If I have 0.9 from 0 to 0.9, so that means I have already passed 0.5, right? I have already passed 0.5. So that's why it's say that then B is contained in A. That means this part 0.5, it's already passed 0.9. So an animal living, so the B is contained in A. An animal living to 40 years old must live through 30 years old. Okay. And then P of AB. So P of AB will be P of B, because you know the probability of living 40 years. So an animal living 40 years means it must have lived 30 years. So we don't consider the 30 year. We just consider the probability of living 40 years. So that's why probability of AB, it will be probability of B, or this part, this 0.5, okay? And then here is the conditional probability formula. So you have to understand this one. A is the, sorry. So here A is the condition. So the condition is the animal has lived 30 years. Yeah, here. The condition is animal have lived 30 years. So here is the condition. We write down the condition after this this line, okay? So here A is the condition. So it means it has lived 30 years. And B is the part we are interested. So we are interested that it is it is living 40 years, right? So the formula will be, we just probability of B where the condition is A. Probability of B contains A, okay? We read this way. Probability of B contains A. So here is A is the condition, and here B is the part we are interested. So it will be probability of their intersection. So probability of AB and divided by probability of the condition. So here the condition is A. So probability of A, okay? So firstly, here is the nominator part. So numerator part. So it is the intersection, and denominator, here this part, it is the condition. So we know that P of AB, it means P of B, and P of B is here 0.5. So we write down 0.5, and then we divide by P of A. So P of A is here 0.9. So 5 by 9, so it will be 0.556. So this is the answer for number 5. So I have drawn a Venn diagram here. So P of A is given living 30 years. P of B is given living 40 years. So P of B, that means living 40 years. The condition is it has lived 30 years. It will be their intersection by the condition. So we know that P of AB equal P of D, and then divided by P of A. So you see here, the Venn diagram is here. This is the total probability part, right? And then P of A. P of A is it has lived 30 years, and P of the value of P of A, it is 0.9, and P of B, it has lived 40 years, so it is given 0.5. And so you see here 0.5 and 0.9. So if the whole part is 1, then 0.5 is here and 0.9 is here, right? So 0.5 is already inside 0.9. So we write down here P of B contains P of A. So that's why P of AB equal to P of B equal to 0.5. So here B already contains A. So we remove A and write B instead. Okay, so this is the Venn diagram. Now let's see number 6. A and B decipher a code independently. It is known that the probability that each person can decipher is 1 by 3 and 1 by 4. Calculate the probability that the code will be deciphered. So here we have to calculate the probability that the code will be deciphered. So here A, we let A is equal decipher the code, and B. Okay, so here we have two person, right? A and B. We have 2 person, A and B. So let A decipher a code, that is A, and B decipher a code, that is B, and C is the code is deciphered. Okay, that means C, it means we don't consider whether it is A or B. We just consider that the code is deciphered. So C will be A union B, because the code can be deciphered by A, and then plus, right? Plus. You know that union, it means or, it means plus. So A plus B. The code can be deciphered by A, or it can be deciphered by B, right? So C will be A union B or A or B, okay? So we need to find the calculate the probability that the code will be disappeared. So we have to find P of C, right? P of C. So we already know that C equal A union B. So P of C will be a P of A union B, and P of A union B, the formula is P of A plus P of B minus their intersection. Okay, minus their intersection, or minus P of AB. And as A and B are independent, so we can write down this part as P of A and then times P of B, okay? So you see here P of A times P of B. And we just substitute the value here. So we will get 1 by 2. This is the probability that the code will be disappeared, or this is P of C. And we have another alternative solution. So it can be also this way, P of A union B. We can also write down this way, 1 minus P of A union B prime. So what it means, P of A union B prime. It means the code will not be disappeared, okay? So 1 is the total probability minus the code will be not disappeared. That literally means the code will be disappeared, right? So that's why we can also use this alternative solution. So A union B, from the De Morgan's law, we know that A union B bar, it will be A bar. Then we just reverse this sign, that means intersection, then B bar, okay? Or you can also write down A bar, B bar. So this is the De Morgan's formula. So we can write down this way, and then as they are independent, so we can also write down their, we can also separately multiply them, and then the answer will be, then we substitute the value here. So P of A bar. So we already know P of A, but we don't know P of A bar. So what is P of A bar? If P of A is equal 1 by 3, then P of A is very simple. Sorry, P of A bar is also very simple. P of A bar will be 1 minus P of A, right? 1 minus P of A, that means 1 minus 1 by 3. So the answer will be 2 by 3, okay? I mean, the answer for P of A bar will be 2 by 3. So we write down here 2 by 3, okay? Or you can also see here like 1 minus 1 by 3. It means P of A bar, because P of A bar is 1 minus P of A. 1 minus P of A. So this is the solution, final solution 0.5. And let's see the next question. Consider the birthday of, oh, so here is the home, here it is the homework 1. Now we go to homework 2. So I'm opening homework 2. Homework 2. Yeah. So the question here is, consider the birthday of 5 people study group. Then calculate the probability that 5 people's birthday are all on Sunday. So birthday, we know that Sunday, that means we are considering here the week. So we have 7 days in a week, right? We have 7 days in a week. So calculate the probability that 5 people. So we have here 5 people. 5 people's birthday are all on Sunday. So probability of all on Sunday. All on Sunday. So you see, we have 5 people in total, and C, we are considering So here is combination, right? We are considering 5 of them. So total we have 5 people, and we are considering 5 out of 5. And then we have no people left, right? As we are considering all of them, so we have no person left. So then why it is 6? Because we have already taken Sunday. So we have only so we had 7 days, and now we have taken Sunday here, right? 5C5. This is for Sunday. So we have taken 1 day from the week. So it will be 7 minus 1, that is 6. So these 6 days, they can be Monday, Tuesday, Wednesday, Thursday, and Friday, and Saturday, right? Because we have already taken Sunday. So times 6 to the power 0, because we have 0 people left. We have taken 5 out of 5 on Sunday. So we have 0 person left. So that's why it is 6 to the power 0. And 7 to the power 5, this is the total probability. Because we have 7 days in a week, and then we are considering 5 people's birthday. So 7 to the power 5. It is the total probability. So it will be 1 by 16,807. So it is a very small probability. And now let's see the second question. Calculate the probability that 5 people's birthday are all not on Sunday. So are all not on Sunday. So now let's see not on Sunday, right? So we have to take 5 out of 5 again, because we are considering the 5 people. We have 5 people here, and we are also considering all of them. So 5C5. And then you see are not on Sunday. So if it is not Sunday, then it can be either Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. That's why it will be 6 to the power 5. Okay, because here if it is not Sunday, so we have 6 days. We have 6 days, and then 6 to the power 5, because we are considering 5 people. 6 to the power 5. So, and then here 7 to the power 5, this is the total probability, because 7 days in a week, and we are considering 5 people's birthday. So the answer will be 0.4627. 0.4627. So I have written here, we don't consider Sunday, so 7 minus 1, that is 6 days. And the third question here is calculate the probability that 5 people's birthday are not all on Sunday. So are all not on Sunday. That means it's not on Sunday, but here it is saying that the people, all the people, they are not on Sunday. Okay, so here it is like people. The focus is people, but here the focus is days. Okay, the correct answer for number 3. So here it was the opposite event formula, right? Opposite event. So we already know the P of A1. So we just find 1 minus P of A. Then we get the correct answer. But here I did mistake in number 3. So you don't consider this one. So let's continue to the next question here. Homework 2. Factory A, B, C produce products of the same model. ABC produce the products from the same model. The defective rate of the products produced by 3 factories. So defective rate of A is 0.3, B 0.2, and C 0.1. And the quality ratio of their product, the quantity ratio of their product is 5, 3, and 2. So in total there is 5 plus 3 plus 2. In total there is 10, right? 10 products. And the defective rate is here For A is 0.3, for B is 0.2, and for C is 0.1. Calculate the probability that the product is defective. So let's say A is the product is defective, and B1 is the product is manufactured by factory A, B2 is produced by factory B, and B3 is factory C. And then from the total probability formula, we know that. So total probability P of A. So the product is defective, right? So we have 0 to 3 because we have three company A, B, and C. So we have 0 to 3, and then we just add them together. That means summation. And you see here P of A P of A, and the condition is BI, and P of B. What it means? So it means that the product BI means it is produced by the first factory, and BI, right? BI or 1. Okay, so here BI, it means B1, B2, and B3, okay? So we have to add them together. And if you look here A is the product defective. So in the question it is said that the calculate the probability that the product is defective. That means we are interested in A, okay? We are interested in A, but we also have to add some condition. Like we have to take the product from either B1 company, or B2 company, or B3 company, right? So B1 means A, B2 means B company, and C2 means B3 means C company. So probability of A, that means the product have to be defective, and we are interested in A. And given that the condition is product is given from the BI company, it can be from A, B, or C company, and then times the product is taken from BI company, okay? So you see here P of A, probability of defective rate of A company. So that is 0. Okay, so P of A. So we have a total 10 products, right? We have total 10 products, and then A produce 5 of them, right? You see here A produce 5 of them, because the quantity ratio here is for A, that is 5. So we have total 10 products. So A produce 5, B produce 3, and C produce 2. So total 10 product. And here A produce 5. So probability of getting the product from A company, it will be total probability, that is 10, and A produce 5 products. So 5 by 10. So it will be 1 by 2, right? Yeah. So here, that's why we write down here P of A. It will be 1 by 2, okay? And then times the defective rate of A here is given 0.3. So we multiply them. 1 by 2 times 0.3. And we know that probability of getting the product from B. So B produced three products. So it will be 3 out of 10. So 3 out of 10 times the defective rate of B is 0.2. And then C produced two of them. So it will the probability of the product getting from C. So it will be 2 out of 10, right? So 2 out of 10, if I just calculate, it will be 1 by 5, right? So here 1 by 5 times the defective rate of C. If I calculate, the answer will be 23 by 100. So now let's go to the third question. A box contains 10 products, 8 of which are qualified and 2 of which are defective. So 10 products, 8 of which are qualified and 2 are defective. Take a on from the box twice. We have to take on product. Each time we have to take on product. So we take 2 times. The first time and the second time, okay? And you only take only on product, right? We only take on product. We only take on product. So take on from the box twice and do not put it back. So once we take it, we should not put it back. Then find the probability that obtained two products are qualified. So two of them are qualified, okay? So let's calculate. So qualified means the first one is qualified and the second one is also qualified, right? And their intersection. So according to the formula, according to the formula of a conditional probability, so we know that P of A2 in the condition of A1, it will be probability of, so here A1 is the condition, right? So we divide by the condition and then we write down the intersection of them, right? So I already said that. No, sir. Yeah, so here, you know, the conditional probability formula, that is here A1 is the condition and we are interested that so where the probability that obtained two products are qualified. So probability of A2 given that A1. So here A1 is the condition. So the conditional probability formula is here. Now we divide by the condition and then we write down the intersection of these two, okay, on the numerator part. And then if you just take the, if you multiply, if you cross multiply this way, okay, if you cross multiply, so you will get P of A1, A2 is equal to P of A1 times P of A2 given that the condition is A1. Okay, so this is just the conditional probability formula, but in a different way, in a different form. And P of A1 is already given, maybe. P of A1. P of A1 is the first company, right? Yeah, for the first chance. What is P of A1? P of A1. You see, I time means the first time. P of A1 means the first time. And then A2 means the second time. Okay. So here A1 means the first time and A2 means the second time. So in the question, it is said that it is told that find the probability that obtained two products are qualified. That means the first product, here first product is A1 and second product is A2. Both of them are qualified. So as we break down the formula, it is this way, right? P of A1 A2 is equal to P of A1 times P of A2 given that A1. So P of A1 is already known. It is known. I mean, you can just look at the numbers here and you can put the value, right? So it's like we have total 10 numbers. We have total 10 numbers. And we know that 10 out of 8, 8 out of 10, 8 of which are qualified. A box contains 10 products and 8 of which are qualified. So we have total 10 numbers and 8 of them are qualified. Okay. So this is the first time because we have to find the probability that obtained two products are qualified. So first time we have 10 products and 8 of them are qualified. And then second time we have already taken the first product. So we should not put them back, right? So then we only have 9 products because we have already taken on product and 9 out of. So the second time it also needs to be qualified because obtained two products are qualified. So we have taken the first product and first time it is qualified. That means it is 8 out of 10, right? This is the first time it's qualified. And then we have now 9 product left. And so, and also we have taken on product from 8. So we have only 7 product, right? So now we write down here 7. Okay. So this is the total number of product. So firstly, the first product, so we in the question it said that obtain 2 products are qualified. So first time we know we know 8 of which are qualified. So first time it is 8 out of 10. And then the second time, as we should not put them back. So now we get only 9 products. And as we have taken on product from the of the qualified part, so we have now only 7 qualified product. And the second time, the probability will be 7 by 9. And number 2, the probability of obtaining the defective product for the first time and qualified for the second time. So defective for the first time, qualified for the second time. So now see here. So defective for first time, that means A1 inverse. Inverse means defective. And qualified for second times means A2. So if we break down the formula, it will be P of A1 times P of A2, given that condition is A1, okay? So you can also break down this way. And let's find what is P of A inverse, or the first time the product is defective. So first time, oh sorry, here it is first time qualified and second time defective. So see here, first time qualified, that means we have all 10 product and 10 out of 8 they are qualified. So it is the first time it's qualified. And as we have already taken on product, so we are left with 9 of them. And it is said that okay, so no, it is defective for the first time and qualified for the second time. Yeah, sorry. So see, it's defective for the first time and qualified for the second time. Defective for the first time and qualified for the second time. Sorry, no, not this one. Defective for the first time and qualified for the second time. So see here, defective for the first time, that means defective means A inverse, and qualified for the second time means, so sorry, A1 inverse, and qualified for the second time means A2. So if we break down the formula, we will get P of defective for the first time and P of qualified for the second time. But here the condition is the first time have to be defective. The first time have to be defective, okay? I mean, if you do not want to break down the formula, you can also think it logically. So here it is said that defective for the first time. So P of A1 is first time, and defective means A1 bar, and then qualified for the second time. So qualified second time is A2, and qualified for the second time is P of A2. But here you have to extra add a condition. You see here, you have to extra add a condition here, because the product is okay, the product is qualified for the second time, but we have already taken the first time, that is the first time the product is defective. So here the condition will be defective, okay, because the first time it was defective. So it means the product is qualified for the second time, but given that the first time it is defective. So let's see here. The first time it is defective, right? So 9 out of 2, because we know, sorry, 9 not 9 out of 2, 10 out of 2, 10 out of 2, okay? So in this answer, it's like written in such a way that it confuses us, okay? So you can understand this way. So first time, 10 out of 2, they are qualified. So as as we know that, sorry, 10 out of 2, they are not qualified. So the first time is not qualified. And the second time is qualified. That means we have already taken on product. So we are only left with 9. And then 9 out of 8 is qualified, right? Because we have not taken any qualified product. So we have still eight probability. We have still eight outcomes, right? So then 9 out of 8, they are qualified. So if I calculate, it will be 0.18. You can see them here. Obtaining defective for the first time and qualified for the second time. So we know that defective for the first time, that means 10 out of 2, they are defective. And qualified for the second time, that means 9. So as we have taken on product, so we have only 9 product left. So 9 out of 10, that is qualified. So we write down here, sorry, 8 out of 9, that is qualified. So we write down here 8 by 9. So the answer is 8 by 45. Now let's see the third question here is the probability of obtaining the defective product once and qualified product another time. Defective once and qualified another. It doesn't matter the first time or second time, just defective once and qualified another. So as we have and here, right? So for and we have to use plus sign because I already told that and means plus sign. So obtaining defective once. So let's say now defective is the second time, okay? So the first time it will be qualified. So 8 out of 10 is qualified. And as we have taken on product, so we are left with 9 product. So 9 out of 2, they are defective, right? So let's say defective for the second time. And then qualified another time. So qualified another time means, let's say now here, the second product. So now here, the qualified another time. So the obtaining defective once and qualified another time. So first time it is defective, and then second time it's qualified. So just let's say the first time it is so previously the first time it was qualified, but now the first time it is defective, right? So here is the difference. You see, defective once and qualified another time. So now firstly we let defective for the second time, and now we have to take defective for the first time. Okay, it means this way. So defective once and qualified another time. So firstly, let's say we take defective for the second time, but then for the second time we have to take qualified. So we have to take defective for the first time. So here we take defective for the second time, and here we take defective for the first time. The same way. So here we take qualified for the first time, but here we take qualified for the second time. It's like vice versa, okay? First time in the defective for the second time, and then second time defective for the first time. So as we take as the first one here, we take defective for the second time. So we have to take qualified for the first time. So 10 out of 8, they are qualified. Then times 9 out of 2, they are not qualified. So this is defective for the second time. But now we have to take defective for the first time. Just a moment, I will receive a call. Oh, sorry, I was taking a phone call. Sorry. So Alex, are you still here?
Yeah.
Oh, sorry. The first one here. Okay. So the question was the probability of obtaining the defective product once and qualified another time. So we don't consider, we don't think of whether it is for the first time or the second time. Just qualified once, defective once, and qualified another time. Or we can also say qualified once and defective another time. Okay. So we don't consider whether it is for the first time or the second time, just defective once and qualified another time. So let's say, firstly, it is qualified. So 8 out of 10 is qualified. And then we are left with 9 products. We are left with 9 products. And so 9 out of 2, that is defective. And then here and, so we know and represents plus sign. And we have now we as at the first time we considered the qualified for the first time, but now we have to consider the qualified for the second time, okay, and not qualified for the first time. So 10 out of 2, that is not qualified, and then we are left with 9 products. So 9 out of 10, that is qualified. So the answer will be 16 by 45. And the number 4, the probability of obtaining the qualified product for the second time. So we just now consider the second time, okay? The second time. So qualified product for the second time. So you see here, for the second time, it is qualified, and here also for the second time, it is qualified. But for the first time, it is not qualified. For the first time, it is qualified here, but for the first time, it is not qualified here. You see, for the second time, it's always qualified. As we are in the question, it said that for the second time, it's always qualified. But for the first time, it can have 2 cases. Either it is qualified and it is not qualified, okay? So and means plus. So now we write down plus sign here. And then as you see here, if there is a qualified for the, here we say, let's write down P of A1, A2. So both of them are qualified, right? And then plus P of the first time it is not qualified, and the second time it is qualified. So then P of A1, A2. First time qualified, second time also qualified. So 10 out of 8 is qualified. So it is the first time qualified. And then 10 out of 7, it is qualified. Then 9 out of 7. 9 out of 7, that is qualified. See, both of them, they are qualified. Firstly, 10 out of 8 are qualified. So now we are left with 9. So, and here we are left with 7. So then, so 9 out of 7, okay? 9 out of 7 is qualified. So first time, second time, both of them are qualified. And plus, first time not qualified, second time qualified. So the same way, you see here, first time, 10 out of 2, not qualified, right? First time not qualified. And then we are left with 9 products, and we see here second time qualified. So 9 out of 8, they are qualified, right? So second time is qualified. So this is the answer for the product is qualified for the second time. Okay. So, and for and we write down plus sign here. The answer will be 0.8. So I think we will discuss the remaining part later. Okay. And I have to take breakfast. Or maybe should we continue? Okay, or maybe we can continue. Just finish the homework too. A machine has 3 independent working elements and the probability of every element damaged is 0.1. So every element, okay, every element, 0.1. When on element is damaged, the probability of machine failure is 0.25. So when on element is damaged, so the probability of machine failure is 0.25. When 2 are damaged, so then 0.6, and when 3, I mean all of them are 3 of them are damaged, it is 0.95. Calculate the probability of machine failure. Okay. So let's say A is the event of machine failure, and BI. So here I means ith element is the first element, element or the second element or the third element. Which element, how many elements are damaged? So BI means I element are damaged, and we have to use the total probability formula here. So the total probability formula P of A, that is summation of I equal 0 to 3, because we have here three elements of that machine. So summation of 0 to 3, and then probability of A, that means the machine failure. And the condition is either first or second or third element is damaged. And then times the probability of the which element, I mean the I element is damaged. So here n-fold Bernoulli experiment, and here n is 3 because we have 3 elements in the machine, or we have 3 segments, right? First, second, and third. The first element is damaged, the second element is damaged, and the third element is damaged. So it is here n-fold Bernoulli experiment, or 3-fold Bernoulli probability. So it is used for solving P of BI. So probability of the first and second and the third element failure. So, and here we are here to calculate the total probability, right? The probability of machine failure, that means the total probability P of A. So it will be the first probability of first element, the first element, if the first element is damaged, the machine failure probability of machine failure is 0.25. So here 0.25, and so we take 3 out of 1, right? 3 out of 1 elements are damaged, and then probability of machine failure for the first element is damaged is 0.25. So we multiply them, and then times remaining. And so as you see that we already know probability of every element damage is 0.1, right? Every element damage is 0.1. So we have, if we have the first element damaged, so 0.1. So we write down 1 minus 0.1, okay? So we get 0.9. So that's why remaining 9 elements, they are working okay. Remaining 2 elements, they are working perfectly fine, right? Because first element is damaged, so the machine failure rate is 0.25, and we take 3 out of 1, right? Because the first element is damaged, and then the remaining 2 elements, they are not damaged. So the probability for so here we just minus 0.1. That means the remaining two parts, it is not damaged. So probability of machine functioning, okay, it is 0.9 because probability of machine failure is 0. For every element, the probability of machine damage is 0.1. So that's why we just calculate 1 minus 0.1. So we get the probability of machine not damaged. Okay, so the first machine, the first element is damaged, so times their probability, and then remaining two, they are not damaged, so 1 minus damage. So the result is 0.9, and then we multiply it using with their corresponding probability, so 0.1. And now let's come back to the second element. So if the first element and the second element, both of them are damaged, so here this is the machine, and first and second element, both of them are damaged. So that's why two of them, right? 1, 2, 3. So two of them are damaged. So 3 out of 2, okay. And then for their corresponding probability 0.6 here, right? When two elements are damaged, the probability of machine failure is 0.6. So 0.6 times 2 out of 3, and then multiplied their. Now you see, if two of them are damaged, so all of them are good. So 0.9 to the power 1 times, and all of them are good, but two of them are not good, right? So then times 2 of them, right? 0.1 to the power 2. That means 0.1 is the probability every element is damaged, and we know that 2 element is damaged. So 0.1 is every element is damaged. Then we know that 2 of them are damaged. So then to the power 2 times, if 2 of them are damaged, then remaining and the last element that is working. So the probability of machine that is working 0.9 to the power. We know that all elements are working, right? So to the power 1. And then for the last, the third situation, the third situation, if when all three elements are damaged, the probability of machine failure is 0.95. So you see the third situation here is plus, right? So we add the situation, the first situation here plus the second situation here, and here is the third situation. So when all three elements are damaged, then the probability of machine failure is 0.95. So here is the probability of machine failure times 3 out of 3 are damaged, and then we don't consider 0.9, right? Because now we can also write down this way, like times 0.9 to the power 0, right? Because none of the elements are working, and no element is working now. So 0.9 to the power 0, and something to the power 0 is 1, right? So 0.9 to the power 0 is 1. So 1 times, and each element, probability of every element damage is 0.1. So 0.1 to the power 3, okay? So this way. There's a formula I mentioned very earlier in this example. Okay, I can write down here. It is like, if you have a closer look here, you will see that. Firstly, the probability of machine failure if three of the components are damaged. So here 3 of them are damaged. So the probability is given 0.95, and then times we are taking 3 of them, right? So 3 out of 3 are damaged, and then times what is the probability of every element damage? This is 0.1. So it's time 0.1 to the power, and then 3 is 3 elements are damaged. So 0.1 to the power 3, and then not being damaged. Not being damaged, the probability is 0.9. And then we know that all of them are damaged. So no elements is working. So here 0.9 to the power 0. Okay. So the answer will be 0.0779. So this is the answer for number 4. I think we can end here because it's been a long time. So I will explain the remaining part from number 5 to from homework 2, number 5, and homework 3, and stage assessment tonight. Okay.
Yeah, man.
Yeah, because
tired.
Yeah, my father called me to have my breakfast, and
it's been like what, 2.5 hours?
Yeah, right. Maybe it's been 3 hours.
That's so long, man. That's hard.
Yeah, right. It's like our advanced mathematics 2 class, right?
Yeah.
You remember the Lu last year?
Yeah, of course I remember her. I wonder why nobody came.
Oh, I texted Grace. She was busy, but I will send a recording. And James, he wanted to join, but maybe it's the night time. Maybe they are sleeping. So, and also for Africans, they are also sleeping now. So I will send a recording.
All right. Thank you, man, for your hard work.
No, it's okay. It's okay. So we will meet again tonight. Okay, 10 p.m. basic time. Sorry, 10:30.
I will not be able to come at 10 p.m.
Okay, no problem. No problem.
I have things to do. Sorry.
Yeah. Yes, no problem. I mean, Grace requested, so I will just doing the time.
Okay, man. Then see you later.
Yeah, sure. I'll see you soon in Shanghai. Maybe this month.
Yeah, bro. I will show you the city around when you come.
Yeah, sure.
All right, man. See you.
Okay, take care.
Bye.